We are in Precalculus. We are starting our new unit, Unit 7. Unit 7 guides are already online, ready for you to fill them out, and they're ready to go. Yeah, so February 11th, 2/11. Today is a beautiful Monday with a lot of vocab, a ton of vocab. All right, so this is that cool unit where it's like review of Algebra 1, review of geometry, review of all these different things. And all of them are really needed for BC calculus, which you don't have to take and you are not going to take. But it's really cool because you can definitely apply calculus to everything that we're doing. So, by the way, cool English fact. So pronouncing this word is arithmetic. I can do adding, subtracting. It's called arithmetic. But if it's an adjective that says this thing is describing a sequence, it's arithmetic. An arithmetic sequence. Usually adjectives that can be used as nouns that end with IC, I think that's the rule at least, they have pronunciation that's towards the end instead of towards the front. So if I'm saying this series is called an arithmetic series, an arithmetic sequence, not arithmetic sequence, that's not the adjective. So it's just a way of saying it. So it's arithmetic. Let's say it together. 1, 2, 3. Arithmetic. Okay. Arithmetic. There's only two things that you need to know for arithmetic. It's plus or it's minus. You're either adding or subtracting. Geometric, what do you want to guess?
Multiplication or division.
Yeah, multiply or divide. All right, so those are your basic definitions for arithmetic and geometric. Sequence. We had sequence in our warm-up. Do you remember what sequence was? Sequence.
Numbers that go after?
I would say pattern, but
Yeah, pattern.
You really need it's one word, list. So an example would be 1, then 2, then 3. There's a list.
What?
Series, however, is adding the list. So I'm just gonna have one word, adding. So my example would be 1 plus 2 plus 3. So slightly different. One is a comma, one is a plus. That's the difference between a sequence and a series. Pretty straightforward so far, yeah?
Yeah.
So I'm going to jump down here to this table, and then we're going to come back and talk about the difference between recursive and explicit. So give me an example of an arithmetic sequence.
1, 2, 3.
1, well, let's make it slightly harder. 1,
6.
6.
13.
No. You have to add the same amount. Yeah. If I added
Oh,
5,
yeah, 5. Also 11.
11, and then add 5 again.
oh, 5.
16.
Yeah, you have to continue the pattern. It's a pattern. And how do I turn that into a series?
1 plus 6 plus 11.
There it is. Plus 11 plus 16. All right. I'll do one for geometric. Are you ready for geometric? 2, 4, 8. What's the next one?
16.
16. I'm multiplying here by 2. That's multiplying, so it's geometric. And it's a sequence because it's a list. Can someone give me a geometric series?
2 plus 4 plus 8 plus 16.
There it is, yeah. In terms of the calculus version of all these, geometric series are really, really fun. If you want to do like really cool art projects in calculus, geometric series is the place to go. Although there's probably a ton of other things that you can do with fractals and stuff. But anyway, recursive. Let's come back to these definitions. So you know what an arithmetic sequence is, an arithmetic series. We're going to be using these definitions on day 1 of Unit 7 for the rest of Unit 7. I'll be like, hey, you remember back to back to lesson 1 where I talked about what a geometric sequence is? And you'll be like, and then you can flip back through and you're like, oh yeah, it's a list, and you just multiply or divide. And I'm like, well, what is a geometric series? It's now adding when you multiply or divide. So we're going to be using these definitions for the rest of the unit. Make sure you know them. All right, recursive and explicit. We'll have these two definitions as well. Recursive. Recursive, especially in programming, you call it recursion, which is the noun version, and this is the adjective. But recursion is when you base your current thing off of your last thing. So what is the current thing based off of just looking straight behind you? So recursive, the definition I want you to write down is find next. You can only find the next value, and then the next value, and then the next value, and then the next value. You can't do it. You can't be like, what's the 100th value out there if I'm here at 1? It's like, I can't find it. I have to do second, then third, then fourth, and then keep going and going and going until I can find that 100th value. You have to just find the next one immediately.
So like n minus 1.
What do you mean by n minus 1? I mean, it's going to come up in our formula, but the reason why we have n minus 1 is a little bit tricky. Explicit means find any. Find any. So with an explicit formula, which is what we're going to be doing tomorrow, here are the notes for tomorrow. I even have them done. Explicit is going to be finding, I can find what the 100th one is just because I know what the explicit formula is. Recursion is, I shouldn't say either one is easier than the other because they're both kind of tricky in their own way, but explicit, you can find any number. All right. And I'm going to be asking you these same definitions tomorrow. Be ready for them. All right, here we go. Recursive definitions. Whenever I have a letter, and this letter doesn't have to be A, it could be B, C, D. It just says that stands for some certain sequence or series. This letter A of 1, this means the first term. Write it down. This is the first term. If I say B of 1, you'll tell me that is the... If I say B of 1, you'll say that is the...
First term.
If I say Z of 1, that'll be the...
First term.
There it is, okay. So the first term here is 7, yeah. Our first term is 7. We have defined it to be 7. This guy right here is the nth term.
First term.
Nth term.
First?
What?
Nth. Nth. If this is the first term, this is the nth term.
What does that mean?
That means I can choose whatever I want to be n. Choose a number, Daisy.
10.
10. If I put A of 10, because now you put 10 in for n, I'm finding the 10th term.
Oh.
Choose another thing, Rochelle, to put in for n.
1 million.
N is now turned into a million, so this is the millionth term. So far, so good? That's what that guy means. Ooh, what is this thing? A of n minus 1. Put a box around him.
No.
Put a box around a n minus 1, or her. I don't know if it's a him or her. This thing right here is the previous term.
I need to know.
I would do the same
Okay,
thing.
I need to know.
I would do the same thing.
The previous term.
This is like when you're trying to find, like, say, like, when x is 10, what's y? And then you have to, like, use n minus whatever.
Yep. So our previous term, and because it's going to be arithmetic, we're only 7-1 is arithmetic sequences. So we're doing adding or subtracting. So what do you want to do? We're going to do the previous term. Do you want to add or subtract a number? Shout it out. I don't care. Say add or subtract 10. Add or subtract 100.
Oh, subtract.
Subtract. What number?
Oh.
Choose a number.
15.
15. That's our rule. We're going to, okay, and this is very important. There's two things for recursive definition. You need a first term, and then you need to be able to find the nth term by finding the previous term minus 15. So put a box around the minus 15. This thing we're going to call the rule. All right, so, well then what is a of 2? What is the, how do I pronounce this thing? This is the what term?
First term.
First term has a 1 in it.
Nth term.
This is the,
Second term.
this is the second term. We know the first term. The first term is 7.
Oh.
Therefore, the second term is, use your rule,
15. Negative 15.
subtract 15 from your first term.
Yeah.
Be 8.
Careful.
Negative 8.
Negative 8. There it is.
Yeah.
All right, so let's write down what that list is, what that sequence is. So we started with what?
Start with
Our
A.
first term.
Yeah, which was
7.
7. Then we got,
Minus 15.
well, that was our
Oh,
pattern.
oh.
Then our next term was
Oh.
Negative 8.
negative 8. What's our next term after that?
Negative 23.
Negative 23, and so on and so forth. It goes on and on forever.
Forever, forever.
Forever, forever.
How do you do the squiggly thing? I can't ever do it perfectly.
Practice. You have to
Oh
practice.
my god. This
I
is so
spent
ugly.
in college. I just spent a whole day just making the curly brace,
Then I
curly
can
brace,
see
curly
this.
brace, curly brace. Eventually, you get better. Should I show you how one of my? She might even be doing it, but this is how my professor always did them.
Ew. That doesn't look. No.
It's very fluid. You can write it a lot faster.
I do this. Look. Watch. I do this.
There you go. Yeah, that works.
What? Oh, yeah.
All right, so let's practice again with our vocab. What is this thing? This 7. What is it?
First term.
First term. How do I say that symbolically?
A1.
A of 1. This is our what
A2.
term? Yep, A of 2, and that is our.
Second term.
What about this guy?
A3.
A of 3, and that is our
Rule. I'm just kidding. Third.
third term. Exactly. Yep. Cool. So we have our whole list, and our list we needed a starting value and then a rule to get to all the rest of the ones.
Wait, Mr. Chanel, will they give us a rule?
On the homework tonight, you're gonna have to come up with a rule. You're making your own rule based off of the pattern. You'll look at the pattern, you'll be like, here's the rule.
Okay.
All right. So notice that it's really hard to find.
Wait. So they'll give us the pattern then.
They'll give you the
Okay,
yes.
wait. Okay, whatever.
There's two different questions. They'll either
Okay.
give you a pattern, make you find the rule, or they'll give you a rule and make you find the pattern.
Okay.
Notice here that you can't find A of 100 right now. What's A of 100? You can't find it.
A of n minus 1 minus 15.
No.
You're really close, actually, but no. You forgot a tiny little part.
A of n. A of 100 equals.
You're farther away now. Okay, let's go to example 1.
No way, I want to know though.
We'll know tomorrow. I'm building suspense. It's a cliffhanger for tomorrow's lesson.
Whoa.
I know, I hate cliffhangers too. I stopped watching
If you hated the white thing, it's us.
because it makes you want the next thing more.
I know.
That's what cliffhangers are designed for. Like, have you ever watched the old, like, 80s Go Speed Racer? Or was it 70s? I think it was the 80s Go Speed Racer. Every single episode ended on a cliffhanger. It was really annoying.
Well, I'll show you that.
Not all shows.
No.
Some shows.
Well, Grey's Anatomy.
There's this thing, I don't know what it's called. It might be called cliffhanger. Did you ever watch This Is Us? It's a pretty good show. Like, I definitely recommend first and second season. Third season is not my favorite, but they don't really end on cliffhangers. What they do is they add extra information to make you ask, why did they give us that extra information? And it somehow relates to the next episode. So it's kind of like the opposite of
Or
a cliffhanger. Instead of not giving you information, they give you more and make you guess on what's going to happen.
Sometimes they give you more information, and it's basically like you're supposed to connect it to the old episode.
Oh,
That's
okay.
what.
That's how Pretty Little Liars worked.
That's how usually like The Conjuring and Annabelle.
I don't remember
Yeah.
Pretty
and
Little
The
Liars
Nun,
doing that.
Actually.
Yeah.
I'll have to think about more. Okay, let's do example 1.
Oh.
Complete this
Okay.
recursive formula for the arithmetic sequence, and here's our sequence. They gave us a sequence. We have to come up with a rule. It goes 101, 205, 209, 213. Okay, B of 1 is what?
101.
Yep. What does this thing translate? B of 1. What's another way of asking that? What is our
Starting point.
starting point or
First term.
first term? Yeah, something like that. So it's 101. Okay, then what is our rule? You have the current term, do the last term, then do what to it?
Plus
La-
4.
Last term, then add 4 to it. Done. You just did example 1. It's that easy.
So we're done?
Well, on to example 2. Yeah, done with example 1. And we have no examples on the back. So example 2. Daisy, you're going to do this one. C of 1 is?
10.
10. And what's our rule? You take the previous term, C of n minus 1, and I do what to it?
Wait, what? Oh, you subtract.
Yep.
Wait.
If I subtract 10, I'll get to 0. I have to subtract a little bit more than that.
Minus 13?
It is indeed minus 13.
Okay.
All right.
I had to think about it.
That's all you have for the homework. Can you do that?
Yeah.
No.
All right. This again, what are we working with right now?
Recursive formula.
Recursive formula for
Arithmetic.
arithmetic.
Oh, arithmetic.
Arithmetic.
Sequence. There
No, it's not a series.
Sequence.
All right, so all together, we're dealing with the recursive formula for arithmetic sequences.
Oh, it says right there.
Yes, it says that. Says that at the title. It says it down here. Just want to make sure we know where we're at. All right, go ahead and write your summaries.